Okay, welcome everybody to our first ever Sigstore office hours. So the idea is this is a place where folks can come in and show us how you're using Sigstore or some cool integrations, or if you're trying to adopt Sigstore and want to get some support and ask questions, this is the place for you. So just before we get started, I do have some just highlights, new and noteworthy things I'd like to share with folks. So, bear with me. First agenda, yeah. I'll go through a couple of new and noteworthy announcements, and then we'll go in. We've got 3 great topics today. So first up, Fabian's going to show us how he's been using Sigstore in production at Edgeless Systems. We've got Seth Michael Larson talking about URL lib3. And then we'll get a latest look on Rust and Sigstore from Luke. And Luke, were you being joined as well?
Yeah, Jotson's here as well.
Oh, excellent. Yeah. And yeah, throughout that, we're open to discussions and any questions folks might have. And then we'll drop into a section where if you're new to the community or looking to adopt it, or really have been around for a while but have questions, then we can go into just general kind of office hour style Q&A. Okay, so a few quick new and noteworthy. Yeah, just wanted to highlight we're coming up to a very fun milestone of 3 million Rico log entries. So I think we should take a poll as to when we're going to hit that exactly. But this is pretty cool because the 1 million mark was hit just at the turn of the year, so end of last year. And so it's been 6 months and we've had another 2 million entries. So yeah, thanks to all those folks who are signing out there, and here's to more growth of Sigstore. And yeah, I wanted to highlight, because I don't think we've made a formal announcement yet, but we do have a new logo, and that's available in different formats, PNG, SVG, and I've put the link there so folks can know where to find them, and we can start propagating it across all Sigstore properties. So if you have presentations you're doing, I encourage you to use the new logo. And just as a heads up, we will be soon pushing through with the rest of the branding logos. Oh, my text has disappeared. Okay. But yeah, as soon as those are officially confirmed, we'll share the locations and encourage people to start using those. My big yellow box there has lost its text, but it did say, if you haven't already given our projects a star in GitHub, please do so, and we'll be looking to get those all up to scratch with the new logos soon. Okay. Quick shout out for the folks who are at the OpenSSF Day. There's a talk on Sigstore by Priya, and that's now available on the YouTube channel. And by the way, these slides are linked from the agenda, so you can go in there and find links to stuff.
Foundation.
Okay. And for anyone who hasn't seen it already, there is a Sigstore course as part of Linux Foundation edX platform. We have had 300 folks sign up so far, so that's pretty great for the first few weeks. The course is free. There is a charge if you do want a certificate, so to just prove you did it. But yeah, highly encourage folks to enroll now. And yeah, it's pretty nice because it gives the context of software supply chain and how Sigstore fits into that bigger picture. And yeah, just a quick shout out to a couple of new blog posts we've had in July. So do check those out on the Sigstore blog. Okay, I'll pause for any questions or comments on those. In the meantime, Fabian, if you start getting ready, and we'll switch to you in a moment. So any questions, folks? Okay, yeah, let's dive into the demo. So yeah, I'd love to introduce Fabian Kamel. Go ahead.
All right, thank you. Should be seeing my screen in a second. Yeah, the topic, I mean, Sigstore in production sounds a bit big. So we have been using Sigstore to sign our released artifacts for our previous release. So it's version 1.3, first time released with Sigstore support, with signatures and verification capabilities. And this is also one point you should take away today. So like incremental is better than doing nothing. So we're still on our way to like securing all our binaries, securing all our product and ecosystem. But at some point you have to start, and like every bit of additional security you get is better than not doing anything at all. All right, so let me give you a brief introduction into what we're doing, what the product is, because it is a bit different than your average like library or like single artifact release. So we at Systems, we are developing products in the space of confidential computing. So if you have not heard of the concept of confidential VMs or enclaves before, it's basically using runtime and memory encryption and isolation. And remote attestation. What this allows you to do is basically rent a VM as you would today at Google, Azure, or wherever. But the cloud provider is not able to look into your virtual machine. It's completely isolated from the hypervisor, from the cloud provider. And you can basically get a signature, the remote attestation part, to prove that your machine is isolated and is running the software you expect it to run. So what this allows us to do is basically use these confidential VMs and now build a confidential Kubernetes distribution on top of that. So we're doing infrastructure. We are like extending core as OS images. We're building binaries for the bootstrapping, some services that run inside Kubernetes to provide some services. So there are a lot of binaries going on. And in addition, we also have this attestation part. So I try to visualize this as high level as possible, just so you see that there are multiple things. So we have the Constellation CLI, which basically is run by the administrator to spawn a new confidential Kubernetes cluster, a bit like kubeadm equivalent, I would say. And this basically deploys our CoreOS image. We also build, this starts the bootstrapper, which actually joins the nodes and so on. And in the end, it will deploy additional services inside the Kubernetes cluster, one of which is used for this attestation part. So the administrator can basically ask the service to verify the node the service is running on. And you get basically a signature that proves that the operating system was not tampered with, for example. I hope this was not too fast. I mean, this is not about confidential computing. If you have any questions or are totally lost, let me know, and I will try to answer the question. But I want to keep it short and high level, so we can get to the signing part. All right. So yeah, first things first. So everything starts with our CLI. So we did that as a first like easy path to get some additional security in. So we're running on GitHub using GitHub Actions, and we used the cosign installer to get the cosign CLI available in our pipeline. And then it was pretty easy, just passing in the secrets, the cosign public, private key, and the password, and then we can use the sign blob to sign our CLI. So as the default use case is for containers, cosign also has this sign blob functionality where you can basically sign any file, any binary you want, and out comes the signature. We can then upload as part of our release if we want to. In parallel, we also use the experimental flag to also upload this to Record, and a few words later about this. But the first use case is basically administrator downloads the binary, downloads the signature, and we also published the public key. So a few considerations on why we didn't use Fulcio, basically. So we generated here our own key. a long-lived key we want to put on some secure device like a YubiKey or something later on. Since we're doing confidentiality and we don't want to trust cloud providers, it didn't really fit right with us to say like, yeah, okay, we're using Azure single sign-on when the whole point of what we're doing is like removing the cloud provider from the trust equation here. So that's one additional downside basically for us in the confidential world, where we're very like the risk appetite, I heard it in the past, is very low for us. We don't want to have a lot of risks involved. So the flip side of that is we will be doing our own key management for the signing part. All right. Then the other thing I hinted at briefly is for the attestation. We need these measurements, and these are basically hashed values or fingerprints of the single components that are involved in the boot chain. So if we look at the typical boot process, we have the firmware like really at the beginning of the boot process, and the bootloader, the kernel, and at some point in time the operating system and other parts that applications running on top of that. So each of these components basically gets its own measurement, its own fingerprint, and the confidential VM is able to basically prove or sign these values signed by the CPU, and therefore prove to the administrator that only the expected code is running inside this virtual machine. We want to make it easy for our customers, so we calculate these values and also publish them as an artifact. But we also need to integrity protect those, that no one tampers with these values, of course. So here we also use the same flow of uploading these values also to Record. This would allow the customer in the end to, as you do with reproducible builds, like recalculate these measurements and check if the same artifact was uploaded to Record in the past and signed by our key. So they can get additional guarantees that, yes, we have signed this. The customer could also state their trust in these values by also signing and uploading to Record. Yes, so these are the two artifacts we're currently signing. As I showed you, we have a lot more artifacts like microservices we're putting inside Kubernetes, and we're looking forward to just extending all the supply chain security and the signatures using cosign. All right, was a very quick rundown. So I would love to open this for a more interactive session. So feel free to ask any questions about like how is confidential different when signing software, or just how we're using Sigstore in our pipelines.
Yeah, and maybe I can start. Like, I don't know if it was we had talked earlier about types of attestations, and are they kind of more variants of attestations you'd like to see supported, or that are specific to your use case that you'd like to see more happen there?
You mean integration with the attestation from confidentiality? So I don't think that cosign could integrate with that. It's already super nice that we have the transparency lock, so customers can basically ask here, hey, are these measurements known, and were they signed by Edgeless or just any other party? And also that we have the option to maybe host some of the components ourselves, just to reduce the trust base even further. I think Luke has a question.
Yeah. So it's not something to deep dive now. We could probably talk about it later.
Yeah.
But there's a project called Keyline. It's outside of Sigstore, but it's remote attestation platform. So it's capturing attestations based on a hardware root of trust. So a similar sort of domain, TPM rather than a trusted execution environment. And they're looking at hashing machine attestations into Record with a timestamp. So that way, at some point in the future, if nuclear war Armageddon takes out all the data centers, you've got this kind of tamper-resistant, time-stamped offline attestation of the machine state at a particular time. So it's pretty cool stuff. It's pretty interesting stuff. So you're happy to chat about it sometime, but yeah, it's a little bit of a lengthy thing to go into now. So
yeah, but the timestamping is a good thing you bring up here. So especially the measurements of lower level things, like maybe you want to update the firmware as a cloud provider on all of your machines. That would mean like all the measurements will be changing for our customers. Yeah. With the secure timestamping in record, this would not be a problem because customer could see like this is the most up-to-date measurements that were published, and there's not a downgrade attack going on.
Yeah, totally.
So do you provide a page on this which tells folks how to verify things and kind of recalculate the measurements?
Yes, we do. So this is also part of our CLI. So these measurements are downloaded from just our artifact repository, or as I said, can also be calculated locally by the user. And then they can basically query their Constellation cluster and check if the measurements they expect are actually like to be found in the confidential VMs.
Nice.
It's pretty cool stuff. It's essentially confidential K8 clusters. The whole thing runs within a protected space. So
right.
The thing is totally abstracted. You haven't got to change your code with some library or anything like that. It sort of completely abstracts that away, and the whole thing runs in a trusted execution environment. It's cool stuff.
Right. The additional value we try to provide is not just having the Kubernetes cluster confidential, but also integrating with all the services the cloud provider has, like load balancing, persistent disks. So everything inside your cluster is just Kubernetes, and everything outside is just not accessible for anyone.
Nice. Great. And yeah, Jake says unblocks a valuable subset of customers. Yeah, no, this is pretty neat. Hadn't heard much about the space, but I imagine I'll be hearing more and more in the future.
I hope so. So if you want to talk more about confidential as Luke, we can also have a separate session just to talk about confidential. It's also super exciting topic.
Awesome. Okay, thanks very much, Fabian. Any last comments, questions from folks? If not, we'll move from the world of confidential computing into Python and URL lib3. Do you have Seth? Hey, Seth.
Hello.
Hey, welcome.
Thank you. Thanks for having me. I'm going to, so I have like a little slideshow, so I'm just going to present.
Yeah, go ahead.
Hopefully that allows. Not sure if you can see at this point. There was like a permission issue.
Yeah, it's good.
Okay, cool. Great that worked first try. Okay, so I can't see the chat or anything like right now, so if you want to relay anything to me, that's totally fine. So I'm Seth Michael Larson. I am currently working at Elastic, but I also do a lot of open source work in the Python space. Specifically, I'm the lead maintainer of urlib3, which is an HTTP client library, and it's currently the most downloaded Python package. And it's one of the core dependencies of a lot of really important packages in the Python ecosystem, things like requests and twine, pip, warehouse, which is the server behind the Python package index. And so because of that, our places were usually the bottom of a lot of different application dependency chains. And so our team is about 8 engineers, all volunteers. Me and Quentin, who also works at Elastic, we are paid by Tidelift to kind of stick around the project, but so we're mostly volunteer group. And our group has a really big focus on security and best practices, just kind of due to where we are in the ecosystem. So we try to, embody that ourselves and also push forward the entire ecosystem by creating content and materials and case studies In the past, we've done a lot of stuff about account security and roles. And in the future, we want to do even more about secure project configurations. So as it stands right now, what we do with Sigstore is we are signing Python distributables. So that's things like wheels and source distributions. Right now, we use Python build to get build reproducibility for Python distributables. And then we sign using Sigstore Python with the GitHub Action OpenID Connect. And right now, what we do on the right is kind of like a little flow chart I threw together about how our deployment pipeline looks. We essentially have a GitHub action which gets triggered on tags, but it doesn't run immediately. We use GitHub environments to require a review to run that GitHub action. And then within that GitHub action, we do a very similar thing to what the Sigstore Python package does for its deployment, which is use the GitHub OIDC, and then after you build all the distributables, you sign them, and then like verify that the signatures actually worked. And currently, what we're doing is uploading the distributions to the Python package index, and then we upload the signature and certificate file to GitHub artifacts. And then it's a manual process of downloading the distributables, downloading the signatures, and creating a GitHub release. And so the addition of uploading the signatures and manually uploading them to the GitHub release isn't a huge deal because our GitHub release creation is already a manual process. It's not automated currently. So it's mostly just having these additional artifacts that we then need to go and grab and attach to the GitHub release. To make sure that nothing gets missed, we actually do have a release checklist, which gets automatically created when a release pull request gets created. And so whoever is the release manager for that day will end up going through the whole checklist and making sure everything is done, including the manual steps.
Seth, can I ask how many different artifacts does your release produce?
Yeah, so we create, every release creates 2 distributables. So it's the source distribution, which is, you should be creating that for every Python release. And then we create 1 universal wheel, which is marked for both Python 2 and Python 3 use. And then from each of those, we sign and we have a certificate. So each GitHub release ends up having 6 artifacts on it.
Okay, thanks.
Yeah. And so that's how we're using Sigstore today. And then just a little bit about like, why are we doing this and what are we hoping for the future? So we're right now on like the super bleeding edge of Sigstore Python. The big thing for us is we want to get a better score on our OpenSSF scorecard, because currently there are ways to sign Python packages with GPG, but it's just not super recommended. It's not where the space is heading. And so we'd rather be exploring this new upcoming space as opposed to living in this older space that's going to be going away soon, hopefully. And so another big motivator is we want to learn about the space, get ahead of the game. If we can be as like an early adopter, help proving the technology, making sure things work, being a collaborator with the Sigstore Python team to help things, test things, make sure things work as expected. Our team is kind of, because of where we are in the dependency chain, we're kind of used to being early adopters. And so we're used to it and we can withstand a good amount of pain there. And then really the long-term goal for us is we want to help other projects by creating materials and examples about how to integrate with Sigstore as a Python project. And then just in terms of like what we're hoping to see from Sigstore in the short and long term, right after this release, there was a lot of discussion about like provenance and identity and how do you verify who is the one that signed and built these distributables. And that seems kind of like an open question right now. Because we're using the GitHub Action OpenID connector, it is mostly just saying that, oh, this was built by a GitHub Action on a repo, which is not super useful for proving identity. We're thinking more like it would be useful to say it was built by a GitHub Action on this specific repo. Like that would be quite useful. or wherever that space goes. So we'll be following along with those discussions. And then long term, we're just super excited about Sigstore's integration with Python package index. So we're also generally following along there. And that is really all I had for my presentation. Anyone had questions?
Yeah, no, that's awesome. Yeah, I love that you're the base of the dependency chain and getting your signing sorted.
I wonder, do you, well, you mentioned that you review deployments before they are released or something like that.
Mm-hmm.
Do you include the reviewers into the provenance, or, I mean, do they add their own signatures, or they are just confirming that the job can execute?
They're only, at the current time, they're only confirming that the job can execute. And so this is trying to enforce, right, Git commits on GitHub are write only. And so we have a really large team. And so single account compromise, being able to upgrade that to publish rights, that would be bad. So we try to mitigate that by requiring reviews before releases can happen. So there's nothing to do with provenance currently with that review process.
I know that TOF, so the update framework, also worked a lot with the Python ecosystem, but this was mainly about the package manager side of things, right? So it basically stopped where you now continue and basically provide good and signed packages to that distribution channel. Is that correct?
Yeah. As far as I know, that is what I know.
All right. Any interest in maybe like extending the PEP in that regard, like so other people can also benefit from what you're doing?
So I think that I can't speak for the Sigstore Python folks, but I think at least another hope of ours is that this goes more the direction of builders, like the tools, as opposed to the people are the ones that are kind of executing these commands, as opposed to like us having to have a completely separate step in our publish workflow. For example, if this was done with Twine, or if this was done with Python build, to just have an extra artifact come out of there, which can be configured in some way. So then all of those things would be uploaded to the Python package index. I'm not sure what the long-term vision is, but I think that is a little bit more attainable, just because like if we asked every single person to do what we did, that would be quite the ask. But if we improve the tooling to make this accessible and automatic, like that would be a little bit more of a win, in my opinion.
Yeah, that makes a lot of sense. Any other folks have any questions? Read a comment from Billy. With regard to source provenance, review attestations, some discussion has started on the Git sign side, and he shared a link so you can see the chat.
One more question from my side. Do you have any blog posts describing the workflows or like mailing lists, something like that?
So we're working right now on, so we have, one second. I am working on essentially some material with regards to the configuring of a project. I have this like template kind of playground where I'm trying to implement as many measures as we can to basically start from nothing and create a project that gets a 10 on scorecard, at least a Python package. And so this is in progress. We're trying to write some materials around this. Sigstore is kind of a part of this, but there has to be I mean, if by the time this comes out that Sigstore Python is still in the place where it is in terms of this is early, not generally available, then it won't be, it'll have the giant asterisk of, by the way, Sigstore Python might want to not use that for now if it's not quite ready, but this is something that we're working on. This is also our playground, just because it wouldn't be great to test out how things work on our main repository. So we use this to create a release and make sure that the whole workflow works before we actually move to putting it on the main repository.
Okay, that's great. And actually, Seth and Fabian, if I could grab your slides after to just make those available, I'd appreciate that. But yeah, thanks for sharing that, and thanks for being on the bleeding edge of integration there. Okay, and so from Python, we're going into the Rust world. So I'll hand over to Luke and Jyotsna. Go ahead.
Great. So yeah, we're going to do an overview of the SixStoreRUS library. And so I'll do a certain amount of time on that, and then I'll hand over to Jyotsna, who's just developed a Recore Rust crate with a full set of Rust API features leveraged within that crate. Okay, let me just make sure I share a screen rather than a window. Okay, so Sigstore and Rust. So first up, SixStoreRUS. Okay, I think that the first thing to highlight is this is a library. It's not a binary per se or a CLI. So it's not seeking to be like Cosign or GetSign. It's think of it like Sigstore or Sigstore-Python. It's a library that people can implement clients on top of. Okay, and it's been a Sigstore approved project for a while now. We've been sort of building it out kind of in stealth, really. It is starting to get some adoption. KubeWarden, CNCF project, uses Sigstore. They sign with Cosign, and then they verify with the SixStoreRUS library, because they're doing a lot of stuff in Rust and WebAssembly. So what's currently supported with this SixStoreRUS library, you can interact with an OCI registry. So if somebody signs something with Cosign and they create a signature annotation in an OCI registry, with the SixStoreRUS library, you can do a full verification of that. We also have tough support in there, so you can verify Recore on full CO roots. And we also have keyless signing, Open Identity Connect keyless style signing, and some other minor functionalities in there as well. And what's coming up is going to have like a kind of a key generation sign-in interface that folks can use, or they could write their own. That's quite a possibility. Ambient credentials. I've got something, a bit of a dirty hack working, but I've got some code where we can run this in a GitHub action. And the main one is community adoption. So starting to ramp up, making some noise about the library so that the Rust community can start to leverage that library. So I'll do a quick demo before I do. So as you can see, we published 2 crates, okay? And I thought what was quite interesting is yesterday we shot up to 167 downloads. So I think folks are starting to discover the libraries there, which is pretty cool. Okay, so what I have here is this is a client implementation that I put together purely for a demo. Okay, you can see that we're inheriting the Sigstore crate, the latest version 0.3.2 that was cut about 16, 17 days ago. And then we have some Rust code. I won't walk through the code, but it essentially performs actions of starting an open identity keyless session. Some keys are generated, encoded to memory. Signing certificate is received. A file is then signed. We generate a signature, the standard stuff that you see. At that juncture, I'm going to bail out before sending anything to Recore. And then I'll hand over to my colleague Jyotsna, who's going to talk about the Recore signing client and crate that she's been working on. So as this is Rust, we're going to compile and run it at the same time. For Go folks, this is the same as Go run, okay? And we've got a sign flag because we want to sign. We're going to spit out a certificate at the end. This is a 4CO provided software signing certificate. We need something to sign, so I'm just going to sign a README file that's in the same repository. It's in the current working directory, and we'll spit out a signature. And then what I'll do is I'll use those artifacts to then use OpenSSL to verify the signature. And what we'll do is we'll pull a public key out of the 4CO X509 certificate first. So I'm just going to bring a little browser up here as well. So you can see, you'll be quite familiar with this, a lot of you. It's very much the same. We've generated a URL there, okay, which is been automatically opened in the browser. I can then log in with the provider that I wish to use. So I use my own personal Gmail. So I log in with Google. Okay, and then we can see that we received the scope from a personal email address. If we look over at the file browser, you can see that a certificate has been generated. We've got a signature file, which is obviously in bytes, so there's not much that we can meaningfully read from that. And you can see that it's about to submit the entries to Recore. I'm going to note there because Jotson will be covering that in a minute. So we've now got signature, a certificate. So if I was to sell X509, you see we've got one we made earlier. You can see this is a standard 4CO certificate. So here's my email in the SAN. You can see the issuer was sigstore.dev. So pretty standard cert there. And what we will do is pull out the public key. Okay. So we see we've got our public key, which is extrapolated from the X509 certificate. And now what we should be able to do is, using the signature that we generated, the file that we signed, and the public key that I just pulled out, the X509 certificate, if all goes well, OpenSSL should verify. So you can see that's verified okay. So obviously the next logical step from this is it would also record this into Recore. And then we could look at providing verifications using Recore as a transparency mechanism. So that's the SixStoreRUS claim. What I'll do is, just before I hand over to Jyotsna, because we're good for time, I'll just check if there's got any questions on this part. No, okay, that's cool. So let me stop sharing there and hand over to Jyotsna.
All right, I'll share my screen.
Oh, you're all right to do the slides from your side, Jyotsna?
Yes, yes.
Cool.
All right, can you guys see the slides?
It's a black screen at the moment.
Yeah, it started sharing, but there's nothing showing up.
Let me just try it again. What about now? I can just try rejoining if you're not able.
You could try that, and I'll get the deck up shared as well.
I'll just try to rejoin just a second.
Okay. So while Jyotsna does that, so that the crate that Jyotsna's worked on, the reason that we did a separate crate is because we're using Swagger to auto-generate all of the APIs. And so it was a bit overburdening to have it in the same library. And folks might want to just use Recore on its own, like Arch Linux use Recore on its own. So it's just a nice, neat crate that they can pull in. What we'll be doing is on Thursday is taking it to the TAC to see if we can get it approved and brought into Sigstore as a project. Yeah, and after this, we'll start networking and getting folks to get interested in using the solution.
Are you aiming for anything like a 1.0 release, or just keeping it?
Eventually, but we're not there yet. Yeah, yeah, but that, yeah, definitely, yeah. Yeah, I think you might be muted, Jotsna.
Yeah, I think I'm not able to share my entire screen. I'll probably just share a tab in that case. Yeah, this should be visible, right? Like,
Yeah, that's what.
Yeah, there we go. That's good.
Yeah, so the aim of this crate is to support like a Rust API client for Recore, and we generated this using OpenAPI, and then we made a ton of changes just so that it's much easier for a developer to like interact with Recore. So like send custom input values and like get back the response from Recore, save it in a proper struct so that he can use it like later. As of now, this is a link to the repository. But we plan to donate to Sigstore, like, if they show more interest. So as of now, these are the list of API calls that are supported by RecoreRS. I'll like go into detail about like how to make these API calls in the demo, but this is the list. And I will go to the demo. I'll have to like switch the window. Just a second. It would be much easier if I could share the entire screen, but okay.
Security,
Yeah. Actually, before the demo, I just wanted to show. Yeah, so this is a repository, so it has a README attached to it. If you want to know more about the API calls and stuff, you can just like generate the docs using this command. I'll put the link to the repository like in the chat later, and I'll like generate the docs. You can like know how to use the crate and stuff. It explains all of that stuff. Now let's switch back. I'm so sorry. It's a little like I keep switching.
Don't worry, you're good.
Cool. All right. So we wanted to make it like very simple for like any developer to use this crate. So we attached like this folder called examples inside the repository. So like inside this folder, you have one file for each API call, and then it tells you how to actually make that API call. So the user, basically like in each file, you have like this comment that explains like, okay, how do you make this call? What are the values that you need in order to like make this call properly? And the user, let's say like, they don't want to actually like, input all the values. They just want to see if the code works or not. You can just like take this part of it and then not provide any input values using the CLI flags. Because like, we have like default values like all set. And I also found that like it was a little more hard for me to like, figure out what values need to like go in order to like, generate a log in the record. So I actually have a file that tells you how to generate like all of these values inside like the test data.
You might have frozen up, Jotsna. Maybe turn your camera off. That might help. Might be the bandwidth. I could give it a little bit more detail. So we started to prototype implementing this into crates and cargo. Okay, so anybody not familiar with Rust, crates is the package manager. It's the equivalent of PyPy, or it's the package repository, and cargo is the, I don't know what you call it. It's the CLI where you can build, run, install. Think of it like the Go command, really, for Go folks. So we're looking to integrate a lot of this into there, so that we can hopefully have the Rust community adopt Sigstore.
Awesome. Yeah, second, Jason says, can't wait to use it. Okay.
Yeah, Michael, you go ahead.
Yeah. I don't know if you're there yet, but have you looked at like CREV, the Rust sort of code review sort of thing? Because I know that they've been looking at some signing of the code, and it could be cool to sort of integrate it there to just have along with sort of the Git sign and everything else. You could just have the code review plugin for Cargo also sort of take Sigstore.
Oh, yeah, I'll definitely look at that. That sounds interesting. So what's that? What's the acronym? CR?
Yeah, I think it's C-REV. Let me just pull it up. Oh, it's just called Cargo CREV. I'll post it in chat here.
I've got it. Yeah, Cargo CREV. Awesome. Yeah. I'll cryptographically verifiable code review system for Rust. Yeah, definitely. I'll get in touch with them. I seem to remember playing with this before, but yeah, good call. Thanks, Michael.
Yeah, no.
Okay, we have another agenda item. Jason, is this yours on transparently immutable tags using Ricore?
Yeah, I didn't prepare much. I can share.
Yeah, give us an overview.
Yeah. Basically, I was talking to some folks about, so from Python to Rust and now to OCI registries. I was talking to some folks about some OCI registry implementations let you say that tags are immutable. Normally, tags are totally mutable. You can change whatever you can push Alpine 316 and update it, and everybody who depends on that by tag now gets your new software, whether they wanted it or not. So some registries let you say that tags are immutable. ECR is like the most, Amazon's ECR is the most common one. And there's a little bit you flip in the UI that says like, okay, now they're immutable, now they're mutable. I was talking to some folks about how we could do better than that. And rather than trust Amazon and your admins from flipping that switch on and off however they want, you could rely on Ricore instead. And so I got nerd sniped myself into building this registry redirector that basically checks with Ricore before it pulls an image. And when it pulls an image, it writes to Ricore, hey, I pulled Alpine 3160 and its digest was, ABC. And then the next time it's asked to pull that, it will check and see if it's ever seen it before. And if it has, and if it's changed, then it will fail. And if it hasn't changed, it'll let it go through. So this is, this gives you a transparent, immutable, transparent record of what tags things pointed to, what digest tags pointed to. Anyway, this is just sort of a fun experiment that I did. Please don't depend on this in production. You are depending on me personally not owning this registry and giving you new software when you ask for Alpine 316. But this was just sort of an experiment to see the kinds of things we could use Ricore for. Sort of just attesting a little, hey, I saw this thing, and then if I try to do something else later, it will fail. It's kind of fun to build, so and it let me use some of the Go libraries in ways that I had not before. So if you are interested, take a look at it. I'm happy to answer questions about it. But there was also a blog post on ChainGuard's blog, which I linked in the notes.
Awesome. Thanks, Jason. Any questions, comments?
Just, it looks really cool. Yeah.
Yeah, do check it out, folks.
I always like to see new inventive ways of using Ricore, and it's cool.
Okay, did I see Jyotsna has made it back in? Sorry about the bandwidth issues. Too bad.
I'm so sorry. I didn't even realize that I was out of the call. I just kept talking. And then I reached the end of the demo. And at that point, I wanted to show something in another tab. So I tried switching and I was like, wait, I'm not part of the call. I got disconnected.
Oh, no, classic. So did you have much more? I want to say, yeah, I think it was pretty early on that it kind of.
So I'm not entirely sure when did I drop off? So what part were you guys
you were sort of showing the example cargo run, so like in the test directory, I think in your test suite.
I see. I think I'll cover it in like 6 minutes.
Sorry, I didn't get it. Do you want to show it now or?
Yes. I should be fine in like 6 minutes.
Perfect. Let's go. Let's do it. And fingers crossed. Luke was suggesting maybe if you want to turn your camera bandwidth off once you start.
Oh yeah, I'll probably do that. Right. So. Yeah, I think I mentioned that I have this file that tells you how to generate each of these values so that inside the test data directory, like the create log entry, it tells you like what values you need in order to like generate an entry in record. So I did that, and I don't know if I mentioned this already, like I might have gotten disconnected already. So if the user does not want to like provide all of these values, he can just run cargo, run example, create log entry in order to create an entry in record and not provide any of these values because we have like default values already inside the code. Like here, you're able to see that like an equivalent entry already exists. That's because I've ran this code like multiple times with the exact same values. But if the user uses like a fresh set of input values and then generates the values for a new artifact, he should be able to like upload the entry without any issues. So this is like create log entry. The next API call is get log entry by index. So the user, the developer can provide the log index that he's looking for. And in this case, we just use like 99. It can be anything. And then it fetches the log entry for that log index. The next API call is the get log entry by UUID. It's very similar to the API call earlier. It's just that this time you're using the UUID instead of like the index, the log index number. Yep. So get log info basically tells you the current state of the transparency log. You don't need to provide any input values. Just run the example by itself. And you get the log info. Get log proof basically generates the consistency proof. You can specify the tree size using the last size and the first size. That's CLI flags. Get public key fetches the public key that you're using to like validate the sign tree. And recall version just gives you the current recall version that the server is using. So search index basically looks up and then tries to find the entries that match the metadata that you provided. Run it again. So it returns back like a bunch of UUIDs. Search log query does the same, but it returns the entire log. So like all of these, I'll show you the example. Right now, so the thing is, this is the only thing that looks a lot more messier. And this is when I lost all of you guys because I wanted to show you this. So like, I want to structure it in a better way. It's just that.
Wow. You there, Jocelyn?
Yeah, like
there was some weird,
again?
some weird feedback loop kicked off.
Oh.
I don't think it might not have been your fault. It's like some feedback loop. Don't worry, it seems okay now.
Did you guys like get all of it, or like did you lose me at some point?
Yeah, we followed along. Yeah.
Okay. A lot of problems this time.
Don't worry.
Yeah, no, thanks for that. We have come to time. I do like your well-documented examples, and maybe we'll have to try that another time if there's much more to add. Always show it at another office hours.
Yes, that's okay.
But yeah, no, thanks everybody for joining. That was great. And yeah, do sign up for more demos or things in 2 weeks. We'll resume. And yeah, we didn't have time for any new questions. But yeah, do let us know if you have any, and we can address them next time on August 2nd. Oh, thanks. Goodbye.
See you later.
Bye-bye.